Okay, in this video I would like to show how to fit a Garch model using MATLAB for some sample data. So the typical Garch model is given with this equations here, 6 and 7. And if you are trying to model the volatility, basically, you will have first a mean equation. So let's suppose these YTs are the log returns of an asset. And if you have some mean equation, you can model that in this step. And the residuals here left that are remaining from the mean equation for this model is represented by this epsilon of t. And in the typical Garch model, we assume that these residuals are normally distributed with mean 0 and with time varying volatility or variance term sigma square t. Okay, so this is time dependence. And to model this time dependence, the Garch model assumes some constant term, and then we have the epsilon, the lagged values of this epsilon squares, and again the lagged values of the previous variance terms. Depending on how many lagged values that you want to include, your Garch model specifications will be different. So let's try to fit a simple Garch 1-1 model. In other words, I want to just use one leg here, t minus 1, so the last period's shock in my return equation. And I want to use the last period's variance term. So I will set P and Q equal to 1. So this is what we call as the Garch 1-1 model, which is very popular, especially for risk management, prediction of the value at risk, or other risk measures. So for this purpose, let's use the S&P 500 data. You can find this from Yahoo Finance. I've just selected the last 5 years time period. You can download this as a CSV file. So I've downloaded that in my MATLAB. And basically, I'm going to just quickly show you the code. So first, after you save this data, I can show you the format of my data. So this is a table after I import the CSV file, and you can save this as a MATLAB MAT file. Okay, this is one way you can store. But the format of the data is very typical for the Yahoo Finance website. So we have the date, open, high, low, close, and we have adjusted close and the volume information about the S&P 500. So basically, what we need is the close prices. We will extract this from our table, from the 6th column, and then I have my dates as the first column. I'm taking this from 2 to end because I'm calculating the log returns here from, I'm losing one observation when I calculate the log returns. So for our mean equation, we don't have much except a constant term. So I'm subtracting the mean of these log returns. So I remove the mean. So I call this residuals as RE. So this corresponds to these epsilons now in our equations here. Okay, so we already obtained this epsilon. Now the thing is, we want to fit a Garch 1-1 model. In other words, we want to find these coefficients alpha or beta, whatever notation you use to represent them. It doesn't really matter. So in MATLAB, in the most recent version, you can directly use this Garch function. You can specify what is the Garch leg and arch leg. So by the way, the Garch leg refers to this beta. I mean, how many legs you want to take for the past variance terms in this equation. That's the Garch leg. For the arch component, we are talking about this Q. So if Q equals to 1, the number of arch legs is equal to 1, or you can increase this obviously. but you need to check whether your t-statistics are significant if you want to extend your GARCH model. So this one is just for the GARCH11, and MATLAB has its generic estimate function to estimate the parameters of such models. The model object is already defined by this MDL. So that means basically MATLAB, you need to input the model specification and then your residuals so that it can estimate the parameters of this model. And then we can also do some forecasting, for example, which is typically you want to also have a prediction about the future volatility. This will also enable you to do a value at risk forecasting for the next, let's say, 5 trading days. So I set this number of days equals to 5. So I am looking to the future 5 days based on my estimated model, number of periods, and given the historical residuals we have. In MATLAB, the default setting is to use the Gaussian. So basically, this is going to be the normal distribution assumption. But you can extend your GARCH11 model by using the T distributed residuals. Okay, so instead of the normal distribution, you can set this as T distribution with mean 0 and another, again, the variance sigma square T. Okay, following again the same equation 7. The only difference will be your assumption about the distribution of these residuals will be different. Okay, then this difference is not actually really much in terms of syntax in MATLAB. You can specify this distribution choice by choosing the T, and you can follow, you can estimate this model basically. The same forecasting you can do with your second alternative model here. So we can call this as second forecast. Basically, if we want to create a plot, let's say, containing the fitted volatility until the end of our sample, but also to include the forecasted 5 days time period together in the same figure, we can combine these inferred volatility term. So this is our inferred or estimated after we fit the model. This is the estimated volatility looking to the past historical data. But if you want to combine this in a nice figure, including also the forecasted values, so I'm using the first model here, but again, you can change this to the second model if you want to use the T distributed GARCH model. And if we run this, we will see, okay, the figure is here. So in the figure, we notice that this is the fitted historical volatility under our GARCH with Gaussian noise term. And the red part here, which is a bit small because our data set is 5 years time period. So let me correct this. Let me just zoom this basically. Okay, so we can see from the zoom that this is the predicted volatility for the next 5 trading days. Okay, so this can be used as an input if you are trying to predict, for example, the value at risk for the next 5 days. And you can also check the estimation results here to make sure whether your model specification is appropriate or not. For the first case, under the Gaussian assumption, we can see that the t-statistics are significant. They are all greater than actually 2, so these are significant, and we can see the coefficients here together with the standard errors and t-statistics, including the p-values. So if the p-values are very small, so they are significant basically. Similarly, you can check the GARCH11 with the t-distribution case, okay, as the alternative. different from the first estimation result. This time you will also notice there is a degrees of freedom parameter, which is the parameter for the t distribution. And these t statistics are also significant. So we can see that Garch11 with t or Gaussian, both of them give us significant t statistics. So you can use these, or you can improve these models, and these can be useful especially for risk management purposes. Okay, that's all for this video.